Hello friends, please this is math and science online class. Please we have something on the board. Please if you come across my video and you find it interesting, please don't forget to like, comment and share. Please we have something on the board here from physics. Please if you're a science student in your secondary school or your high school or you are still in your tertiary institution, you are studying any engineering course or any physics related course in your tertiary institution, please you need to listen to me. Let's solve this particular question on the board on the electric circuit. Now, we have an electric circuit here on the board. As you can see, we have an electric circuit. We are asked to calculate the current I flowing through this circuit. Now, this current, we are going to ask you to calculate the current flowing into this electric circuit. As you can see, in this electric circuit, we have the resistor and we have the battery here. The battery, the 12-volt battery. Now, this electric circuit will have resistors being connected, 2 ohm resistor, we'll have the 10 ohm resistor, and we'll have the 5 ohm resistor. As you can see, we are going to, for us to find the current flowing in this electric circuit, we need to first of all find the total resistance of this resistor. Because this is the resistance of this resistor is 2 ohms. The resistance of this resistor is 5 ohms. So we are going to find the total resistance. Then after we must have found the total resistance, we now use our Ohm's law to find the current flowing in the circuit. Now, for us to find the total resistance, we need to start from here. This side that doesn't have source. Start from here, we will find the total resistance here. As you can see, if we start from here, we'll have 2 ohm resistor and we'll have a 10 ohm resistor. So these 2 ohm resistor and this 10 ohm resistor, they are connected in what? In parallel. This is parallel connection. Now in my other classes, I'm going to teach you about the connection of resistance in series and parallel. Now as you can see, this one and this one are connected in parallel because if current is flowing through here, when current gets to this particular point, it will split. So this resistance and this resistor here, they are connected in what? In parallel. So we are going to solve this in parallel, then keep it in series with this 5 ohm resistor for us to find the total resistance. Now, as you can see from here, the formula for finding the total resistance or the resistance in parallel is written as what? You have the product over sum. But let's assume, or let me break it down for you. For those of you who are still babies in physics. So let's assume. Let me remind you. If you have here R1, we have this one R2, and we have this one R3. Now for us to find the total resistance here, we all know that total resistance is 1 over R total is equals to, for parallel, this one and this one they are in parallel. This will give us 1 over R1 plus 1 over R2. Now, if you look at here, the LCM here is R1 and R2. So here we have R1, R2 divided by R1 is R2 times 1 is what? R2 plus R1, R2 divided by R2 is R1 times R1, R1. So this simply means 1 over R total is equals to is R1 plus R2 all over R1, R2. So here if we cross multiply here, this one multiply this one. So here we have R total, R1 plus R2 is equals to R1, R2. So here we want to make R total the sort of the formula. So we divide both sides by R1 plus R2. R1 plus R2. So here this one will cancel this one. So R total is equals to R1, R2 all over R1 plus R2. That is the product of the resistance all over the sum. So this is how I got it. So I'm going to use this particular formula now to solve this one. So if you use it to solve it, then the series connection, when resistors are connected in series, we are going to sum them up. We are going to sum them. So we solve these two in series, then we now add it to this one. That is how to get our total resistance. Now let me clean this. I will show you how I got my formula. I'm going to use the formula now to solve this. So for here, for us to find here, this one will give us because 2 ohm resistor, 2 ohm is parallel to 10 ohm. So here we'll have 2 times 10 all over 2 plus 10. So this will give us 20 over 12. 20 over 12. So here we'll have 20 over 12. We calculate as 20 over 12. You can use your calculator. 20 over 12, which is approximately 1.6667 ohms. So this is the total resistance in parallel here. So for series connection, we are going to put this in series. So our circuit, we take this shape. We have this. These are 12 volt battery, the current I. These are 5 ohm, and this is 1.6667 ohm. So as you can see, look at how the circuit has taken a new shape now. Now this 5 ohm and this 1.67, they are in series. So we add them up to get our total resistance. So our total is equal to 5 plus 1.6667 ohms, which is 6.6667 ohms. So this is our total resistance. Now we found our total resistance. We are asked to find the current flowing through this circuit. Now don't forget, current always flows through the circuit, while the voltage flows across. Voltage flows across. So in my other videos, I'm going to teach you the difference between the current and voltage. Now you are asked to find the current. Now the current, for us to find the current, we know our voltage. Our voltage is 12 volts. Our current, we don't know. Total resistance, we have 6.6667 volts. Now we are asked to find the current. Now remember, from Ohm's law, we remember that V is equal to IR, and this R here is the R total. So we are going to make I the sort of formula because we are looking for R. So I will give us V over R total. So our I will give us our V is 12 all over 6.6667. So we divide this, get our current 12.12. We have 12 divided by 6.6667 equals to. So our current here is approximately 1.80 amps. So our